โอเคครับ What do we have? So good afternoon everybody สวัสดีครับ then I need to share the screen, right? Okay, permission in order to so what happens ทำไมผมแชร์หน้าจอไม่ให้คุณไม่ได้เหมือนว่าเขาไม่ให้ผมแชร์หน้าจอในมีตนะครับให้ทำไงดีเลยแล้วผมต้องเปิดสไลด์สอนคุณด้วยคนไหนเป็นเจ้าของห้องนี้ permission ทำไมคราวที่แล้วไม่เห็นมีอะไรเมื่อวานนี้นะครับก็ยังแชร์หน้าจอให้คุณได้ so what happens say is any solution for that โอเคคุณจะเห็นดีเนี่ยบัตรที่แต่ว่าที่ YouTube นะครับจะเห็นหน้าจอนะหรือว่าผมต้องออกใหม่ดีกว่าครับแล้วเข้ามาใหม่เผื่อว่าจะแชร์หน้าจอได้ครับentire screen this one okay I think it's possible now right Okay. So let's talk about the first person. คนแรกนะครับ the first person การตัดพลครับการตัดพลขอผม no. ขอผมเห็นหน้านิดนึงนะครับอยู่ตรงไหนเอ่ยครับอันพลได้ยินไหมครับ Hello can you hear me กำลังเช็คชื่อนะครับโอเค M604 right this is SCI33205 can you hear me ได้ยินผมไหมครับ
ได้ยินครับ
การตัดพลคือลาใช่ไหมผมจำในไลน์ไม่ได้ขอนิดนึง
เปล่ามันหลุดแป๊บหนึ่งครับ
อาจารย์ครับเมื่อกี้ผมหลุดครับผมได้ที่ 1อาจารย์
ตรงข้อผมการตัดพลมาแล้วนะครับ
มาแล้วครับ
โอเคK คืออะไร6-4-10ลาโอเคlet me see what happens 604เดี๋ยวดูไปด้วยนะครับเพราะว่าคนนี้ชื่อเคเลขที่10หรือเปล่าnumber 10 president ลานะครับคนแรกโอเคชวินชวับนี่หมายเลขอะไรไม่รู้นะครับส่งรูปมาเฉยโอเคคันทัพพล please let me see you for a while ให้ผมเห็นคุณหน่อยครับคันทัพพล
ครับอาจารย์
Okay, it's fine. Thank you very much. Kantapon presents the second one. พิเชษพงศ์ครับ
Yes, sir. I'm here. Right here.
Yes, but I cannot see you.
Oh, sorry, sir. Sorry, I'm here. Present. Hello.
Thank you very much. The third one, พัฒนิน
สวัสดีครับอาจารย์สวัสดีครับ
พัฒนินที่ไปมหิดลนะครับ
ครับผม
โอเค Okay, I can see you. Present. And nothing. Okay, the fourth person.
มาครับ
เพตรา
ครับ
เรียบร้อยครับโอเคครับ The fifth one ณัฐพัฒน์ครับ
ครับผมอยู่นี่ครับครับ
อิทธิกุลโอเค maybe a little delay on my side it's no problem the sixth no sixth is German the sixth person ภาวินครับ
วันนี้เขาเหมือนจะลานะครับผมเห็นเขาส่งใบลาอยู่
sixth one I'm sorry for that six
อาจารย์ครับตอนนี้ผมย้ายไปเรียนใน YouTube ได้ไหมครับ
โอ้ตามสบายครับคนที่ผมเรียกแล้วเชิญเลยครับทำไมรูปในไลน์ไม่ขึ้นสักทีว่าใช้อินเทอร์เน็ตเยอะหรือเปล่าหรือว่า Okay, this one. รูปไม่ยอมขึ้นครับโอเคเฮียนี่เลขที่8เนี่ยชวินเลขที่8เคนี่เลขที่10พร้อมหมายเลขพร้อมนี่หมายเลขตัวเล็กมากกิติพัฒน์18หรือ19อะไรประมาณนี้นะครับผมจะพยายามจำนะครับ19ขุนน่าจะ18 19 but I cannot see the letter from number 6เพื่อนบอกเวลาแล้วทำไมผมไม่เห็นนี่ยังลาอยู่ใช่ไหมครับ Any idea นี่ครับเลขที่6หมายถึงว่าจดหมายครั้งที่แล้วโอเค fine for the same reason right เตรียมตัวให้โอเค the second one
สวัสดีครับ
ฮาวิเชิญครับ
สวัสดีครับ
ฮาวิโอเคbut your camera okay it's fine 7 number 8ครับ
ขออนุญาตไปเรียนที่ YouTube นะครับ
ตามสบายครับไม่ได้ลง number 8ชวินครับชวิน
ชวินลาครับ
ชวิน8เนาะผมใช่ for the same reason right
ครับ
ผมก็ไม่ได้ทำไฟล์ก่อนเพราะยุ่งอย่างอื่นของคุณนี่แหละครับThis is วันหลังพิมพ์ด้วยนะพิมพ์ด้วยหมายถึงว่าคุณส่งจดหมายมาผมต้องมานั่งไล่ดูมันเสียเวลาครับคุณพิมพ์ด้วยว่าคุณหมายเลขอะไรชื่อจริงอะไรขอลานะครับไม่ใช่ส่งรูปมามันก็แต่ผมต้องมานั่งไล่ครับให้ข้อมูลง่ายๆนะครับเลขที่8ชวินชวามาโอเคwhat is the reason for ตัว IL number 8 and let's go to the next person สุระประวีณครับแล้วประวีณเห็นอยู่ดีแต่ว่ายังได้ยินผมไหมครับ
ได้ยินครับ
ก็เห็นเรียบร้อย the next person เหมือนว่าลานะครับกัสสิดิตเคใช่ไหมครับคนชื่อเคโอเค yes ตัวสมัยยืดเข้ามาใช่ไหม number 10 is hereเดี๋ยว11ปัญญาครับปัญญา11พิมพ์เอาแล้วผมจะเห็นได้ไหมครับเนี่ย11จะว่าขัดข้องเรื่องกล้องหรือว่ายังไงยุ่งจริงนะครับ11ทำไงดี
มันเปิดกล้องครับแต่มันไม่มีไมค์ครับ
เปิดกล้องโอเคฝ่ายโอเคฝ่ายเห็นแล้วครับวันหลังเอาอันนี้คือกล้องมือถือหรืออะไรของคุณให้ผมเห็นหน้าคุณตอนนี้คุณให้ผมเห็นข้างคนที่เหมือนประจำเลย ผมจะได้จำหน้าคุณได้ด้วยครับครั้งหน้าให้เห็นข้างๆนี่ตัวคุณจริงหรือเปล่าครับ alright banyak yang ini ini banyak 11 right turn your camera to let me see yes หมายเลข11นะครับคุณเปิดหันกล้องนะครับคุณเช็คชื่อทีไรให้ผมเห็นข้างตลอดเลยครับทำไมมันมืดๆนะครับ11ครั้งหน้าช่วยจัดการครับ11 so let's go to the number 12คนนี้มารอก่อนเลยครับ12ทัชชกรนะครับ
มาสวัสดีครับ
ครับรูปคุณเท่มากครับโอเคทัชชกร thank you very much 13นภัสครับ
ครับผมอยู่ครับ
นภัสขึ้นรูปไหมครับโอเค fine 14ลพิษครับลพิษ
อาจารย์ผมขออนุญาตไปเรียนใน YouTube เลยนะครับ
ตามสบายเลยครับลพิษนะครับโอเคมืดๆนะครับโอเค15วีรพัฒน์ครับ
ครับผมอาจารย์เห็นผมยังเอ่ย
วีรพัฒน์เห็นคุณอยู่รูปหน้าขึ้นเรียบร้อยโอเคครับ16สุภสินครับ
จ้าสวัสดีครับ เห็นไหมครับ
สุภสินรอดูครับอ๋อขึ้นแล้วสวัสดีครับ
ผมขออนุญาตไปเรียนที่
ตามสบายเลยครับตามสบายเลยครับครับก็15คะแนนนะครับขอเช็คตามเข้มงวดนิดหน่อยคุณไม่ต้องสอบคุณไม่ต้องทำรายงานอะไรเลย17อัครวัฒน์ครับ
สวัสดีครับเห็นผมหรือยังครับ
อัครวัฒน์เห็นช่องคุณอยู่แต่ว่าโอเค fine
ครับ
thank you very much 18ปองพลครับอัญญามิตรครับ
ลาครับผม
ทีนขุนนะครับคนชื่อขุน18เขียนมาลาfor the same reason right โอเค19กิตติพันธ์ครับ19ฮัลโหล19ลาเหมือนกันใช่ไหมครับ
ครับ
จดหมายเลข19คนชื่อพร้อมโอเคคนชื่อพร้อมยังสบายได้หรอครับเหมือนเขียนเหมือนเดิมเมทาสิกครับเมทาสิก
แป๊บนึงนะครับกล้องเปิดอยู่
ครับ
สวัสดีครับ
สวัสดีครับเรียบร้อยครับแสดงครับ21ชัยสิทธิ์รัฐโยธิน
นะครับ
ว่าถ้าเป็นไม่ใช่เสียงไลน์ผมนะโอเคมาใช้สิทธิ์เรียบร้อยครับ22ทินพัฒน์ไม่รู้ลาหรือเปล่าครับคราวที่แล้วเขียนว่าลา22 is there any idea about him so let me see the letter ละ3ของอะไรนะ22ทินพัฒน์จดหมายเขาจดหมายเขียนลาถึงรวม26ด้วยป่ะalso 26 okay it's my task to remember. The 12, okay, including today. 23 ทันธนานัทนะครับ
มาครับ อันนี้เห็นกล้องไหมครับ
โอเคเรียบร้อยครับ fine 24 พี่สุดไม่รู้ลาด้วยหรือเปล่าเดี๋ยวดูในไลน์24 any idea แต่นี่จดมาโอลายาครับ24 until 27 right okay everything is fine ที่ YouTube นะครับไฟล์ให้ผมให้คุณเห็นไฟล์ครับโอเคมีไฟล์นี้นะครับเช็คชื่อเสร็จเรียบร้อยครับคุณจะอยู่เปิดกล้องหรือไม่เปิดกล้องไม่ซีเรียสแล้วครับผมจะได้มีสมาธินะครับthen we go to the direction, right? But I don't understand why. Cannot see what's going on. Okay. เดี๋ยวผมขออนุญาตเข้าห้องน้ำนิดนึงครับ Okay, fine. At the YouTube side, can we increase on should be fine. We arrive at the problem, right? The problem about Bristol law. need to go to the chart. Right. Okay, we already started. Okay. On page 82. It's better if I make it. Okay, we have finished. Okay, we have finished the problem about the angle of the refraction, right? The angle of refraction ถ้ามีอะไรเร่งด่วนนะครับก็พิมพ์มาครับหรือว่าพูดออกมาทางนี้ได้เลยครับเพราะว่าผมเปิดลำโพงอยู่นะครับ so we would go ahead with this problem, okay, because there is another part of the problem. There is another part of the problem. It's before that we solve the problem during daytime. Okay, this is the daytime, right? We have the sun on the left side, okay, and that's the start of the light, which is a kind of electromagnetic. And there is no light at all at the bottom of the swimming pool. That's the daytime. Okay, let's go to the next scenario when we are at nighttime, and due to the security reason, the owner of the swimming pool, let me check the voice whether it's fine or not. Okay, in the nighttime, okay, the sun has gone away. Okay, the sun has been away, and we don't care about the moonlight. Okay, we assume that the main interest for us เหมือนว่าเมธาสิทธิ์พูดอะไรหรือเปล่าเบชนะครับno กดผิดนะครับ Okay, the main source of the light during night time the owner of the swimming pool, okay, has arranged a spotlight, okay, a high intensity lamp, okay, which is the kind of source at the bottom, at the ground of the swimming pool, and now we have here the lamp, okay, the lamp of at the bottom of the swimming pool, and we assume that we don't care. Okay, we don't pay attention to the light from the moon. Okay, I assume that everywhere, yeah, about the water, of the water surface in the swimming pool is dark. In let's consider the situation when the light here propagates from the source, okay, which is a high intensity lamp. Now it starts from the bottom or the ground of the swimming pool, and it propagates through the to the boundary. Okay, again, we don't the environment here doesn't change. Okay, we still have the air above the water surface. We still have the water, okay, with the same index of refraction, and the light from the high intensity lamp, okay, that hit the boundary of two substances, okay, the air and the water, okay, in the swimming pool. And of course, there will be two components as the output. Okay, this is the input, and here will be the output. Okay, the first output is the reflected component, and the second one will be, okay, the one which is reflects to the water. Okay, and the question to this problem is an underwater floodlight is turned on in the swimming pool for security reasons. And repeat two previous questions for rays from the floodlights that strike the smooth surface. Okay, we still assume that there is no no one who is swimming, okay, in the swimming pool. Okay, the water surface is assumed to be smooth, okay, or planar, and we are gonna repeat two questions in the former situation, okay, in the daytime. The first question is, what is the polarizing angle? Okay, if you can remember the question yesterday, what is the polarizing angle? What is the angle actually that makes the reflected components to be linearly polarized, okay, or completely polarized? Okay, in that case, this one should get a spatial value. Okay, the incidence angle should be spatial value, which is exactly the polarizing angle, and that polarizing angle can be determined from the principle. Right? If you can remember, as you have done the homework, tan theta p equal ND by NA, right? That's the formula we have seen yesterday. And for the next question, the second question is they just asked us about the reflecting angle, okay, the output angle when the light has passed through the second substance, which is the air here. Okay, we don't we consider the reverse situation. Okay, before that, during daytime, the light starts from the air, right, and it passes through the water, and part of that has been reflected to the air again. But in this scenario, the light starts from the water itself, okay, and of course there will be two components as future. The first one will be reflected component, okay, it returns to the water, and the second component, it just passes or go through the second matter or substance, which is the air here, and now the leg of the light in this component is no longer the reflected one, okay, but rather the refracted one, okay, because this is the component in the second subset, okay. So we need to get back to the whiteboard, and I'm going to solve this one for you, right? Close this one so that you can get best internet connectivity for the this one we need to stop presenting and now ผมไม่รู้ว่าคุณดูที่กล้อง อันนี้ชัดหรือเปล่าครับแต่ว่าดูเหมือนไม่ชัดเลยเนาะผมย้ายมาที่กล้องจริงๆดีกว่าครับ I hope that you can see just right there and link what happened it seems that something wrong with the camera. Just go to board and I need to change microphone actually. this one. Use the external. Okay, we still have the same environment, but every method stay same as the previous situation, but the light source has been changed. Okay, from the sun to the artificial light source, which is the lamp for the second situation. I hope that you can hear me well, right? ถ้าไม่ได้ยินที่โปรดแจ้งผมได้เลยนะครับโปรดแจ้งนะครับถ้าไม่ได้ยินครับเดี๋ยวผมเปิดไลน์ดูด้วยแล้วกันเผื่อคุณไม่กล้าเปิดไมค์บอกครับ I'm gonna use this one. Right. Okay. We have again the two scenarios. Two substances. This is the water level. Okay, this is the water level, water surface, which is the boundary. We are going to look at these scenarios in 2D view. Okay, the side view, and assume that this is the normal. Okay, the normal line, which is 90 degrees with respect to the water surface, and the right, the flat light, okay, is over here, and here is the ground of the swimming pool. Okay, everybody can hear me, right? Oh no, this one. Okay. This is the ground or the bottom of the swimming pool, and the light can go to any direction, but we are interested in the light that propagates in this direction. Okay, it's just propagate in this way, and of course there will be two components. The first one is this one, which is the reflecting components. I would say reflection. Okay, and there will be another component, which is the one here, propagate in this direction, and this one, I hope that it's not beyond the upper border of the whiteboard. Right. I hope that it's not beyond the upper whiteboard. Okay. And this one here as well, right? Of course, this one will be the angle which is called incidence angle. Okay, it's theta I actually, and this one will be theta R. Okay, theta R, and this one is theta B for us in this scenario. In this example we have done yesterday, we call this one as the substance A, right? Then we call this one as the second substance, which is substance B. But in this scenario, the light start in the previous scenario, in the former scenario, the light start from the air, right, to the water. and one of that is reflected to the air again. That's why we say A and B. But in this case, we are going to change because we use A as the first homogeneous substance and B as the second homogeneous substance. We use now in this situation the light starts from water, so we would say this one is the substance A. Okay, everything is fine. We're gonna say that this is the substance A, and this one is gonna be substance B. Okay, because this is the first substance that the light propagates, and here will be the second material that the light will pass through. And now A and B. Okay, and the question is what is the reflecting? Okay, reflecting. This is refraction right now. Okay. What is the reflecting angle, which is theta r? Okay, but according to the second rule in the geometrical properties, we are going to say that the reflecting angle will be equal to the incident angle. Okay, and in order to get complete polarization or linear polarization, okay, we assume that this one has linear polarization. It means the polarization. It means that the E field of this one, okay, just aligned in this way. Okay, just the E field is aligned in this way. Okay, for the reflecting components. And we are gonna say this will happen when this angle is equal to this one, and this one is equal to a spatial value, which is polarizing angle. Okay, theta p is polarizing angle. Okay. And when we make the light we let the light propagate with this angle, we're gonna get linear polarization. Okay, that's the first that's the condition you need to know, and we can find theta p from the Brewster law, right? Again, we are gonna apply the Brewster law to this scenario. The Brewster law says that tan theta p equals NB by NA. Okay, and that's the first question. And if we would really want to find theta p, we're going to use the inverse function version of this equation, right? It's arctan. I hope that everybody has done or submit the homework, okay, the assignment. And here we get the version which is ready to use, okay, the arctan formula. And we would again remind ourselves the n, the index of refraction for the air is 1, right? And the index of refraction in water is 1.33. Okay, you can if you can remember, you have that, and we are gonna leave those values into this to this expression. It's going to be arctan, right? Arctan of what? NB. NB is the second substance. Right now, it's going to be in air. Okay, the second substance is air. The denominator is the the value in the first substance, which is right now in water. Okay, it's water. We leave it like that, and we put the value into this expression in octane. In air, what is that? Air is 1 divided by in water is 1.33. Okay, and you will see that this you just use the calculator to compute the arctan of that. Let me open the calculators. Arctan, right? Arctan of 1 by 1.33 and times 180 and by pi, right? By pi, and there you get approximately 37. Let me again on the Meet, on the Google Meet site. What is the octal? Where is the octal calculator? เดี๋ยวครับผมไม่ใช่นั่นอ๋ออยู่นี่โอเค octal Okay, in YouTube, I have already shown you the how to use the calculator, right? You may use two steps, right? You just find first the ratio, the value of 1 by 1.33, and then you leave it into the okay, for the people in Meet, it take quite a long time. โอ้นานมากเพราะว่าหลายอย่างครับ Okay, maybe I use the terminal, maybe faster. Okay. Oh, I forget to share the screen to you, right? The screen here. Okay, and then even this version. Okay, here, right here, we get this one. Okay, okay, on the Meet side, we have to place arctan, right? Arctan 1 by 1.33 and times 180 divided by pi. What you get will be this one, right? It's 36.9, 36.939, okay, which is the same, approximately the same as it's approximately 36.939 degree, or approximately 37 degree. Okay, for simplicity, you get theta p in this scenario. And for the YouTube side. Okay, I forgot to bring you to okay. On the YouTube side, here is the way to calculate the angle. Okay, arctan 1 by 1.33, 180 divided by pi, and you get the result on the whiteboard like this. Okay, 37, and we go ahead. That's the first answer for the second scenario, and let's go to the second question. Okay, we need to find the reflecting angle here, theta b, and what is that in this case? Okay, in everything is all right, and as you as you can remember, when we let the light propagate with a spatial value which is called polarizing angle, theta p here, this angle, maybe I didn't draw it appropriately. Okay, it's the angle between the reflecting component and the refracting component will be 90 degrees to each other. So this is 90 degrees, and with this one, we got to know this one already. It's 37 approximately. Okay, 37 degree. We have got this one, and the summation of these two angles should be 90, right? So theta b. So theta b, which is the angle measured for the reflecting ray with respect to the normal, will be 90 degree minus theta p. Okay, and theta p is what we have seen here, 37. Okay, it's going to be 90 degree minus 37, and it's approximately 53 degrees. Okay, and that's it for the second scenario at night time. Okay, we get back to the lecture notes again. Okay, we go to the lecture notes. Okay, it might be quite slow on the okay. So we go ahead on the lecture note. Okay. If we go further on this, okay, this is the solution. You have got which is 37. Okay, polarizing angle is the 37 degrees, and reflecting angle, okay, will be 53 degrees approximately. Okay, and we go ahead with that. Now it's going to be the application section, which has no longer computation. Okay, there will be no computation at all for this case. Hello. ได้ยินไหมครับ on the meat side, I don't understand what that is. Yes, on the mid side, you can hear me, right? Okay, we go ahead with the radio, the application of electromagnetic wave ที่มีได้ยินผมนะครับที่มีฟัง Google Meet นะครับไม่รู้ว่าได้ยินผมหรือเปล่าเลย Okay, we go ahead with the application of the electromagnetic wave. This one, we first consider the radio. Let me check whether you can hear or not on the mid side. Okay, everything is fine. The radio or audio communications have many varieties. Human has used it. The electromagnetic wave since our grandfather generation. Radio was the first technology. Actually, it was applied in militaries, and after that, it has expanded into the commercial application. Okay, you may see that the war is not good, but war is the area where human has invented the cutting edge technology. And okay, it's not popular for your generation, but during my father generation or my grandfather generation, the radio technology was quite exciting at that time. Okay, radio was the first technology that uses the electromagnetic wave for telecommunication, communication over long distance. Okay, this is the branch in electrical engineering, actually. So you can see here the DJ. Okay, the person who manage the radio station. Okay, she is at the radio station, and she tries to arrange the radio program. Okay, and she just put her voice, okay, into the microphone, which is the same as me right now. Okay, and the voice, okay, which is the mechanical wave, okay, at the beginning of this chapter, is transformed into electrical pulse. Okay, electric signal is sent over the cable line, and it's the electric pulses are modified or adjusted a little bit, okay, for better quality or for any other purposes. Okay, and the signal will be further, as you can see here, will be modified a little bit at the transmitter, which is the signal processing unit. Okay, and it's transferred to the transmitter, okay, which is the radio amplifier, and it's transmitted through the cable, okay, into the antenna, and the antenna convert the strong electrical signal into electromagnetic wave, and then electromagnetic wave will be propagate, okay, in all direction to this radio station antenna, and this is the tower for the antenna. A radio transmitter converts sound wave into radio wave, okay, which is a band of our electromagnetic waves, and broadcast them. Okay, the meaning of broadcast is that we send the electromagnetic wave, okay, in a very broad way. Okay, that's why broadcast here in different directions. So in all direction, if you want to send your signal, okay, your voice in every direction, this antenna should be the antenna of the omnidirectional type. Okay, the electrical impulses are converted in radio wave. Okay, that are later broadcasted by the transmitter. So if you study the telecommunication engineering like me, you are going to see some more detail, okay, the stuff inside here, but it was old generation already. It's not popular like now. Let's go to the detail of this one. Okay, radio receiver. Okay, let's take a look at our side. Okay, if you stay at home, you have the radio. Okay, I'm not sure it's not popular in your generation, because in your generation you should stay mainly with the Sony PlayStation or any kind of game devices. But during my age, okay, we were quite exciting with the radio receiver. Okay, but it's not for your time. Okay, FM or even AM channels were quite popular during my age, or even my brother sister age generation. In radio receiver, in many locations, let's get back to the ancient generation. Okay, let's consider this, because it's a kind of our theory in electromagnetic wave. Just pick up the radio wave and convert them back into sound wave. Okay, you can simply see the whole structure of radio receiver. Okay, but if you want to go into the detail, okay, I think this is beyond the scope of your high school level. Okay, if you study telecommunication engineering, there will be receiving antenna. Okay, this is the receiver side, and there will be band pass filter. Okay, we cut down the frequency out of our scope. Okay, because the frequency out of our main interest just has nothing for us. Okay, no information. It just it just provide us only the noise and interference and so on. Okay, we need to increase the strength of the receiving signal or waveform from the air. Okay, we increase the strength and we demodulate it. Okay, because whether you use or you receive the AM, okay, amplitude modulation or frequency modulation, you need to have the demodulator. Okay, they means down. Okay, or convert back the signal. Okay, from the signal that is modulated with carrier. Okay, carrier means for example, if we talk about the FM. Okay, each radio station will be assigned with a certain frequency. Okay, not all FM radio stations will get the same frequency. Okay, each radio station will be allowed to use only a certain frequency, and if you want to receive the music from that for any particular station, you need to turn your carrier frequency. Okay, you just need to change the frequency, central frequency, which is called carrier. Okay, carrier to a specific value of the frequency of that radio station, and that's the way we change the number, like 100.75 megahertz. Okay, that's the case here at this block. Okay, you just change your radio receiver to have a certain central frequency in order to get the signal, okay, the channel from that radio station as you want. Okay, and after that you can get the voice from that radio station, and you have this one, the triangle. Okay, which is quite which is the same shape here. Okay, this is the typical drawing in engineering. Okay, we use triangle to represent the amplifier. Okay, this is the amplifier to increase the voice level. Okay, the gain of the voice that you receive. What you receive from the modulator may not get enough volume, so you increase the volume at this block. Okay, the audio amplifier, and then this one is connected to the speaker, and then you hear what you get from the radio station. Okay, you can see that there are many steps actually, but if you don't get into the detail what the telecommunication engineer work, you just simply understand that radio receiver convert the radio waves to the sound wave. Okay, this is the radio wave here at the receiver side. Okay, at the input side of this block, the whole block here. Okay, and here is the output. Okay, what you get from the radio receiver is the sound, right? It's voice or the music from the radio station. This is the radio wave. The radio wave reach radio receiver and are converted back into sound. Okay, let's go to the next application, which is not entertainment. Okay, previously the soldier or military used this diagram, okay, for their communication in the war, but that was the cutting edge technology in the ancient generation. But after that, when we don't have war, okay, we use the same technology for transmitting the music and so on for commercial purpose. But let's get into another technology which is related to electromagnetic wave. ถ้าเลยเวลาบอกผมได้นะครับ radar. Okay, radar stand for most of you may have ever heard the word radar, right? If you are interested in health science and so on, you may not have ever heard this one. But radar has also a commercial application nowadays. Radar also start from military purpose. Okay, the scientists have invented the radar for military application at the beginning. Okay, everything start from military purpose, right? Okay, and radar actually comes from the word. Radar comes from the word radio detection, okay, and ranging. Okay, what does that mean? Human uses the radio, okay, which is a kind of electromagnetic wave. Okay, they detect the radio wave. Okay, it means they sense that there is the signal, okay, in the band of radio spectrum. And another activity to do is ranging. Okay, what does ranging mean? They just use any algorithm or calculation method to expect or to find the distance between the source of this radio wave, okay, and how far is the source of this radio wave, okay, and that's called the method of ranging. Okay, detect and find the distance of the source. Okay, detect the signal, the incoming signal, and find the distance of the source. That's the meaning of radar. Okay, the radar. The radar. Actually, as I told you, started from the military application here. They still use it nowadays. Okay, the human still uses the radar technology nowadays. This is the this is the radar station. Okay, you can see it in military as well, or even at the airport. Okay, there will be a radio station at the airport. They use also such kind of radar station, okay, in order to detect the airplane. Okay, and here is the application. Okay, when there is a war, the military is going to bring the radar station. Okay, this is the receiving side and also the transmitting side. Okay, they just transmit the radio wave. Okay, and when that radio wave hits any object, okay, it will be reflected and it will return to this antenna. Okay, and you just use the calculation, use the formula of the speed of the lights and so on. Okay, you can get the distance. Okay, that it means you detect the incoming radio wave and you calculate how far. Okay, what is the distance of the source of the reflected component of the radio wave. Okay, it starts from World War II. Okay, any country that can develop this technology will have the advantage in the war. This is from 1939 to 1945. Okay, is a way of detecting the aircraft and the ships from a distance and estimating the locations. Okay, if you know the position of any object, it's benefit for you. Okay, you can do what you want when you know this information. Okay, if let's take a look at the detail of that figure. You have radar transmitting side. Okay, this one can be the same. Okay, this is the radar receiver side. Okay, TX stands for transmitting side. Okay, RX means receiving side or receiver. Okay, this is the transmitter. They just transmit the radio wave. Okay, and radio wave will propagate in the straight line. When it goes in any direction, but because only the line that is direct to the target, any target that you are interested in. Okay, when this line propagates to the target, it will be reflected. Okay, from the target, and you get the return signal or return radio wave. Okay, with this actually the return radio wave will be in any direction. Okay, in all direction. But we consider only the one which is right away to the receiver. Okay, because the other components cannot be detected by other people. We are here. Okay, and we want to find the distance. Okay, when we receive the returning reflected components, we can we can place the receiver and the transmitter in a very close location to each other, or we can even place it in the same position actually, and you can calculate the distance, right? You can use the velocity of the lights and calculate everything. I think we still have 20 minutes more. This one is the reflected wave, or sometimes they call echo wave. Okay, they can use the radio region or even microwave. Okay, if you want high accuracy results. Okay, this is the principle, and you can apply this principle to any application. Okay, to the military application or the commercial application. And here is what you can see actually on the radar screen. This is the 2D. Okay, you can, if you scan in the whole area, you can see where any airplane locates. Okay, and that's useful. Okay, if you are the owner of a country, you need to know the information of any flying object above your sky. Okay, your area. so that you can control your security in the whole country. So this is the application of the radar technology. Okay, even we don't have the war, we still use the radar technology to find any object in our sky. Okay, and for the commercial application, radar technology is also applied. It's called, we want to control the air traffic at the airport. Okay, we need to know where any airplane locates. Okay, if we don't know, we can get the airplane crash. Okay, and that's the sad story. Here at the ground station, which is in radio control tower at any airport, we're gonna have this radio tower at any airport. Okay, and when in a technology that is uses nowadays, it's called ADS-B. Okay, ADS-B means automatic dependent surveillance. Okay, automatic dependent surveillance broadcast. Okay, broadcast is the last one after the Dutch. Okay, is a cooperative surveillance technology. Okay, we cannot use simple ranging in the previous figure. Okay, we need to use more cooperation. Okay, from several objects, even the flying object, so that we use even the communication. Okay, the connection between the GPS satellites. Okay, in order to identify the location of the airplane. We also have the communication between two airplanes, and we need to get the radar information for any airplane, and then we can perfectly find the location of the airplane. Okay, the details of this system is beyond your level. Okay, if you go into the detail, I think we would not have enough time. Okay, but at least you can see the overview application of the radio wave propagation or application. Okay. Here, we can also use the radar technology to the weather weather condition forecast. Okay, we can predict what is going on in the next few days or the next few days, right? Using the radar station. Okay, as I mentioned before, and how could we use it? Okay, we just have the transmitting side. Okay, at the station we transmit the radio wave. Okay, and this radio wave will go propagate through the air, and it will hit any object as the one. For example, we let the direction of this transmitting radio wave into the sky, so you will get the radio wave will hit any object. For example, the raindrop. Okay, and that signal will that radio wave, which is a kind of electromagnetic wave, will be reflected, and it will return again to the receiver side. Actually, it goes to any direction, but it cannot be detected. What is interest for us is the reflecting component if we are at the station. Okay, and then we can find the distance of this raindrop. Okay, and when you know how far it is, you can predict. Okay, you can tell the people in your country or in your area that this raindrop is going to propagate to us with this velocity, and we can even find the time. Okay, how much time this raindrop is going to be in our area, and so we can give this weather forecast to the people around the station. Okay, and this is the one of the applications of the radio wave technology. Another way is another way for radar application is to find the speed of any object. And if you are the police, okay, you may want to find the speed of any auto or any car. Okay, you just again transmit the microwave or radio wave, and it will hit the object, which is the car, and this wave will be reflected to you again. Okay, it's called radar gun. Okay, and then when this car move, okay, then you can calculate, which includes the Doppler frequency. Okay, you can calculate the distance or the velocity actually of this moving car. Microwave reflected by the moving car have a different frequency from the microwave emitted by the radar gun, according to the Doppler effect. Radar led to the invention of the microwave oven. Okay, this is the miracle application. Okay, this person is an engineer. He is a radar engineer. Actually, his name is Percy Spencer. Okay, this person was working at Raytheon. Okay, Raytheon, which is the name of a company related to radar. He stepped in front of a magneton. Okay, what is magneton? Have you ever seen a movie which is called X-Men or something? There is a guy whose name is Magneton. Magneton is the device that powers the radars. Okay, it emits the microwave. Okay, and because he's just a routine working person, he put a chocolate bar into his pocket. Okay, and when he stay in front of the magneton, okay, I hit the magneton, and the magneton, for example, this is microwave station. Okay, when he works, and he stay in front of this radar transmitting device, and he put the chocolate inside his pocket, and what he found is that the chocolate in his pocket has been melted. Okay, okay, it changed from the solid phase to the liquid phase. I think we still have 5 minutes more. Okay, and later he found that this is the result from the microwave. Okay, microwave collect its energy into the chocolate bar, and it has been melted. He just form up a pattern. Okay, he just create a pattern, and he used this principle. Okay, the microwave transmits its energy into any object, which is the chocolate bar. Okay, and he discovered the microwave, and you get his legacy nowadays, which is microwave oven. Okay, and that's the story about microwave oven that was created in the past. Okay, I think we are running out of time right now. Right, 14, 19. Here is the result. Okay, the chocolate bar has been melted because of the radar microwave radiation. And here is the peptide. This is the magneton. Okay, and that's the principle why the people why Percy Spencer has created the microwave oven in our world. So the cellular telecommunication technology will be addressed next time. Okay, we need to quit our lecture. We don't have homework at all for this time. We have only the explanation. Okay, there is no problem to solve. So see you on next Wednesday. Bye bye ครับ สวัสดีครับ
ครับ สวัสดีครับ
สวัสดีครับ This one, we need to
Deflecting